Hey everyone, what I want to do is go over exam two. So these haven't been entirely graded. They're about halfway. I'm about halfway through. But I just want to create the video now. So let's do number one. So this is very similar to a homework problem, and I believe either homework 4 or homework 5. Um, Basically the same setup. Here it's a little different. You're finding the interest rate, but you can figure out the payments. So you make a $75,000 investment in the following way. You purchase an annuity immediate with 30 level annual payments at some interest rate I. Payments received are immediately deposited into a fund earning 6% interest. So we're going to find I if the accumulated value of these payments after 30 years is 300,000. So I need to find first what the payments are. And that's pretty straightforward from the information I'm given. The accumulated value of these payments is 300,000. So just use the formula. Let's say P is the payments. So I have 30 of them. This account earns 6% interest. So let's just use our calculator to figure out what this is. 300,000 is the accumulated value. 30 and 6 interest, compute payment, and we get P is 379467345. As always, if you want to round to nearest decimal, nearest penny, that's fine. Don't care how you round. All right, so these are the payments. So now I can figure out what I is. So I'm purchasing a $75,000 annuity. That's my investment. I purchased a $75,000 annuity. And so I mean $75,000 as always is the present value of my annuity. So we know the payments are P. And so let me store this. So it's a 30-year annuity. We don't know what I is, so we're going to have to use the calculator to figure this out. TVM. So this is my payment, 30N. So I have to make 75,000 negative. Otherwise, I'll get an error. So compute I, and we get 2.9356. Yeah, so let's go to the second problem. So this is where a time diagram definitely helps. So we have an annuity with effective interest rate of 2% per period for the first 30 periods. So this is again very similar to one of the collective homeworks. And has an effective interest rate of 3% for the next 20 periods. Payments are at the end of each period, and they're 500 for the first 40 periods, 400 for the next 10 periods. This is also very similar to one of the class examples. Actually, there's a very slight modification to one of the class examples. But it's still similar, not exactly, but similar to one of the homeworks. Okay, so let's draw a time diagram. Okay, so first and foremost, 2% interest for the first 30 years, 30 periods. For the next 20 periods, it's 3%. 400 for the next 500 for the first 40 periods. Payments are at the end of each period, so starts at t equals 1. I'll just include these. I'll add more if I need it, but I don't do. Okay, and for the last 10 periods, it's 400. Okay. So we have 3 instances of a interest rate or payment change. We have an interest rate change at t equals 30. We have an interest payment change at t equals 41. So I have to break this up into 3 annuities. Okay, so if I remember, that's how we did this problem. So really at t equals 40 is kind of when the payment change occurs, because that's the beginning of the payment period where we start to have 400 payments. 40 to 41 is the payment period where the 400 payments at the end of each period start. Okay, so we have again two changes in either payment or interest at t equals 30 and at t equals 40. So we have to break this up into 3 annuities in between each interest rate or payment amount change. Oops. All right, so we're finding the present values. Let's do the easy one. Let's just do these 500 payments here. That's 500, a 20.02. That's genuinely given at t equals 0. Sorry, it's 5. It's a 30-year annuity. That's these payments right here. I'm going to erase this because it's going to get very crowded very soon. All right, so let's do I'll do 31 here. Let's do these payments here, or this payment periods here, this 10-year annuity that I just circled. So the present value is at the beginning of the first payment period as always, so that's at t equals 30. So it's 500. Here interest is 3%. And it is a 10-year annuity. So because this gives me present value t equals 30, I have to discount this at 2% by 30 years. So discount it, so it's minus, or I think I've been doing 1 over the past couple of. I probably go back and forth, but this is a 300 level math course, so you shouldn't be set between negative exponents and fractions. So it's 30. It's 500 A10. And last but not least, so let me get rid of this. Sorry, bear with me for a second. All right, so now we're going to take care of these payments. Or this annuity, 10-year, 10-period annuity, where the first period is 40 to 41. All right, so same idea. The beginning of this payment period for this annuity is t equals 40. 400 a 10.02. Because interest 0.03 rather 0.03. But that interest is 3% from 30 to 50. All right, so this is at t equals 40, so I discount by 10 years at 3%. And then another 30 years at 2%. So I discounted to t equals 30 at 3% because interest is 3%, 30 to 40. Then 30 to 0, 0 to 30, interest is 2%. So I discount it by 30 years. Okay, and yeah, let me double check this real quick. 410.3. Sorry, this is 30. I said it, but I did not write it. Okay, so right. All right, so I guess I'll just go into my calculator and do this. Good double check. All right, so shouldn't take too long. So 500 payment 30N to interest compute as a value. This is going to be 11,190 point. I'm not manipulating anything at this point. I'm just going to add these three numbers up. So I can just round. I'll still store it into one spot because why not? Make life a little easier. All right, so let's get the second one here. So 500 payment, 10N, 3% interest, compute present value, times 1.02 to the minus 30. Just try that one more time. Great. 500 payment, 10N, 3 interest, compute that value. Times 1.02 minus 30. Yeah. So it's 2, 3, 5, 4, 64. And last but not least, let's get this one here. All right, so 400 payment. Yeah, it's so easy to make a stupid mistake when you're recording something while you're entering into a calculator. Kind of your mind is being kind of mine is in like two complete different places at once. But anyway. All right, so take this times 1.03 to the minus 10. Move this out of the way. And then times 1.02 to the minus 30. 140,166. So it didn't save the second one, but that's all right. Take this plus the first one plus the second one. 2, 3, 5, 4, 64. And we get 14, 954 and 53 cents. So it's a bit of a pain, this problem, but it's really not that bad. All right, so another problem similar to really problem 1. And similar to homework. Again, I think it's homework 4. Wrong, but to make deposits of 500 at the end of each month into an account earning I-12 is 3% for 2 years. At the end of the 2 years, you take the accumulated value and purchase an annuity, 3-year annuity that makes monthly payments of X at a nominal monthly interest rate I-12 of 6%. Find X. All right, so so for 1 and 3, you have to, just like the homework, you just have to know what's going on. You have to understand what annuity is and understand, can't just plug into a formula and poof, get your answer. Okay, so let's just think about what's going on. We have deposits of 500 for 2 years at the end of each month. So deposit of 500 at the end of each month for 2 years. Okay, so we're going to take the accumulated values. We want the accumulated value. So 500, there's 24 monthly payments. Accumulated value, it's at the end of each month. So it's annuity immediate. Same thing with the other annuities we've been dealing with. This exam, payments are at the end of each period, year, whatever. All right, so monthly interest is 0.3 over 6. So it's 0.0025. J is the monthly interest, 0.03, the actual effective monthly interest, or just the actual monthly interest. So it's 0.0025. Okay. So let's see what it says. 500 payment, 24N, 0.25%, 12.35 and roughly 41 cents. Okay, so we're taking this amount and purchasing an annuity immediate. Okay, so we're saying the price of this annuity immediate is 12.351 and roughly 14 cents. Okay. And always, the price of an annuity, if you're doing loans, or we're doing loans now, the price of a loan price is always going to be the present value. Okay. It's the price of a loan, of an annuity, of a mortgage, is how much all these payments are worth right now. Okay. And by price for mortgage, I mean the mortgage amount. Okay, so just use present value formula. X, A is a 3-year annuity at the end of payments are at the end of each month. Monthly payments of X. So 36 monthly payments, 3 times 12. And interest here, well, I-12 over 12, 0.06. 0.005. So A 36.005. All right, so yeah, let's just, well, this amount is right here, so I don't even need to store it. So this is my present value, 36 N, 0.5% interest, compute payments, 375 and 75 cents. Those are my payments. Payments that I'm getting from this annuity. Okay, right, so the problem 4. So this is basically exactly the same thing as one of the homeworks, except instead of an annuity in perpetuity, it's an annuity, it's a 50-year annuity. All right, so pays 100 at the end of each year for 20 years. So I'll just go that. At the end of the 21st year, payments increase by 2% each year. So this is sorry, I don't know why I have 500, it's 100. So this is going to be 100, 1.02. I'll do another one. Two squared. Oops. So, all right, so what's the payment here? This, I usually write arrow for present value or accumulated value. This just means this is the payment here, so I don't want to cause confusion. I'm just literally running out of room here. Right, so the pattern is t equals 20, it's 100, t equals 21, 1.02, t equals 22, 1.02 squared. So whatever we add to 20 is the exponent, 0 exponent, 1 exponent, 2 exponent. So it's going to be 30 here. So the payment is 100, 1.02 to 30. Okay. So I want the present value. So I take the present value of my first 100 payments. So 100A. So I like to start actually a geometrically increasing annuity without increasing it. So let's just take the first 19 payments. You could do 20, but then this geometrically increasing annuity would start at 102. That would be the starting payment, 102. Interest throughout this entire annuity is 4%. Okay, so right, so we've taken care of these payments. All right, so now we're going to look at all these payments with the payment period starting at t equals 19. Okay, so this is going to be a 31-year annuity. So it's going to be 100. Well, it's going to be, just use my formula for a 31-year annuity where the first payment is 100 and each subsequent payment increases by 2%. So that formula is 1 minus 1 plus 0.02, 2% increases subsequent year over the interest rate of 4%, 1.04. This is 31 over 0.04 minus 0.02. 0.02. Okay. Now this is going to give me the present value of t equals 19, so I have to discount this by 19 years. So 1.04 to the minus 19. So let's get this value first. $100 payment, 19, and for interest, compute the present value 131339. So Let's store that in the one spot. Don't bother writing it down. All right, so let's get this kind of messy thing here. And so this is a 19. Look like it. Okay, so let's get this thing first. That's the easiest way to do this. 1.02 over 1.04. Raise it to the 31. Make it negative plus 1 over 0.02 times 100 times 1.04 to the minus 19. And we get 107,332. So add it to my first amount, and we get 2386.71. All right, so another slight modification to a homework problem. Find the smallest integer n for which deposits of $2 at the end of each period has the present value. I think for homework I did accumulated value. It has a present value of at least 40 if there are 28 deposits at 4%, followed by n deposits 3%. So just like in the homework, I'm going to draw a time diagram. I think I even said when I did the solution video for this for the homework problem associated to this, the homework problem this is basically the slight variation of that. When I first did it without the time diagram, I actually got it wrong because I haven't looked at this stuff since I last taught it. So draw the time diagram. Okay. So what's going on? You have 28 deposits at 4%. Followed by n deposits at 3%. So here it's 3%. So $2 deposits throughout. So that's not really anything difficult. Okay. All right, so let's write stuff down. Not that you really need this, but this one here. All right, so let's do these $2 payments first. So, well, present value, let's solve for n, it's 40. Using the calculator, then we'll round up to nearest integer. So, yeah, this is these payments here to a 28.04. Figure that out in a second. So now let's take the present value of these other payments. So definitely I've been stressing, because it's a very important concept, that, you're taking present value at different time periods. You have to discount it if it's not present value at t equals 0. That's really one of the main points of this whole, the lectures on annuities. All right, so let's take care of these here. So, sorry. We already took care of the t equals 28 payment with this annuity. So we're looking at these payments of $2, 28 of them, where the first beginning of the first payment period is t equals 28. Okay, so this is going to be 2an. This is 28 to n, so we don't know what n is. This is n periods, 28 to 28 plus n. Sorry, I said 28 to n. It's 28 to 28 plus n, so that means it's n periods. At 3%, we have to discount this by 28 periods at 4%. So times 1.04 to the minus 28, or 1 over 1.04 to the 20. All right, so let's get this amount here. So 28N. So if I look like I'm squinting, I apologize. This emulator is very small on my laptop, and it's just downright freaking hard to read what I'm even entering, and this is the biggest it gets. Sorry. 2 payment, 28, and for interest, compute present value. So let's add 40 to it. So we get 6.6738. I'm going to store that into one spot. So this whole thing here, I'll just write it 6.67387 is going to be 2AN.03. Okay, so let's solve for AN.03. So divide by 2. Sorry. Yeah, I divided by 2. I multiplied by 2 times 1.04 to the 28, and it should be about 10. It's 10.00648 is AN.03. All right, so we got to be a little careful here. So implicitly, there's a 1 in front of this. So let's say this is my present value. Then we have to make the payments negative. Otherwise, you get an absolute garbage answer of, I think, minus 8, which doesn't really make sense. What the hell is n equals minus 8? How do you have minus 8 payments? I mean, that's getting philosophical, kind of. I don't even know what that means. I mean, mathematically, the point is you can plug in anything you want in n into the annuity immediate present value formula, but realistically, n has to be a positive integer, or in theory, it could be 0, but it's obviously not here. So anyway, that's payment, 3, interest, compute, n. So it's 12, so I'm going to round up, n is 13. So I won't do it, but you can plug in 12 and see that when you plug in 12 into here, you get less than 40. If you plug in n equals 13, you get more than 40. Plug in n equals 14, you'll get more than 40, n equals 15, more than 40, etc., etc. So this is the smallest integer where we have more. The present value is at least 40. Anything larger, and we have anything smaller, and we have less than 40. Again, you can check that. Plug in 12, it's going to give you less than 40. All right, last but not least, like I said, I like these problems. So, all right, so 25,000 is deposited at t equals 0. So we have 25,000 at t equals 0 into an account earning 4% interest. At the end of each year, interest plus 500 is withdrawn. So no subtlety here. At the end of each period, we keep withdrawing $500. Okay. So yeah, each time we have another t, or no, it's 25,000 minus t times 500. One too many zeros here. Yeah, that makes a lot more sense. Sorry about that. All right, so it's freaking annoying. Move this out of the way. All right, so yeah, so let's take 25,000 minus 49 times 500. So that's 500, then finally 0. All right, so well, nothing's deposited here because at the end of each period, we take that year's interest plus 500, dump it into the second account. So again, I want the amount deposited, not the amount, not the accumulated value at the end of each period in the account. We're going to use our formula to figure that out. So it's 500 plus 25,000 times 0.02. The second account earns 2%. So it's 500 plus 1,000. Same thing, 245. Let me make this bigger so I can actually fit this in here. Still a little challenging, but it's all right. 24500 times 0.02. So it's 500 plus 980. This is going to be 960. 500 plus 24000 times 0.02. Sorry. Yeah, this should be 0.04. I don't know why I have 0.02. Someone actually made this mistake. Yeah, like I said, it's when you're focusing on making a video, it's so easy to kind of say one thing and just your brain is in two completely different places. Anyway, right, the second account earns 2%, but the first account earns 4%. So we're taking the interest earned at the end of each year from the first account and depositing it into the second account. So it's 4% of 25,000, which is actually 1,000. So that's correct. 0.04 times 25,000. 4% of 24,500 is 980, et cetera, et cetera. So this is going to be 960. This would be 1,000. 4% of 1,000 is 40. And this is 500 plus 500. 4% of 500 is 20. So we have a decreasing annuity. $50-year decreasing annuity. 20, 40. So it's 50 times 20, 49 times 20. I'll just write that. Let's see if I can. Usually this doesn't work. Let's see if I can get it to work here. Okay, I think this might work. Yeah, so just like before, this is 20 times 50, 20 times 49. Et cetera, et cetera. This is 2 times, or sorry, 20 times 2, 20 times 1. So it's a decreasing annuity. So we have our constant annuity of 500. We want the accumulated value. So 500 S 50. The second account earns 2%, so 0.02 plus 20 DS 50 0.02. 50-year decreasing annuity. The last payment is 20%, 20, and interest is 2%. All right, so just dump it to here. Oops. Clear TBM. This is payment 50N to interest compute future value 42,289.70. 42,289.70. Plus well, the formula is 20. 50 is N 1.02 to the 50 minus S 50.02. I have a room here. All over 0.02. All right, so this here, you can dump into your calculator. Well, I'll just do it real quick. It's easiest to get this first. So let's make it one payment, and this is kind of nice because I'll get a negative answer anyway. So take this plus 50 times 1.0 to 50. And just the numbers work out. You get 50. I don't know. Pretty surprising, but you do get 50. Divided by 0.02 times 20. That's 50,000. So you get 92,289.70. All right, well, hopefully this helped. And you definitely have to understand annuities solidly for bonds. You have to understand loans and annuities. Sorry, we're doing loans now. You have to understand annuities for loans and bonds. So if you did not do well on the exam, definitely watch the video and learn how to do this stuff. We're not going to use everything in this exam, but we're going to use a lot of it. Just the basic formulas for annuities are going to be the foundation of loans and bonds. So yeah, this is a core. This is the course, basically. This is the core of the course, annuities. All right, only two more, actually, week and a half. For only a week and a half until the last exam. It's absolutely crazy. But it is what it is. And yeah, so long. Take care. Yeah. Bye-bye. Take care. Bye-bye.